Let us start lecture 29, and today's discussion will be some case studies based on passivity of a metal and its interaction with the cathodic polarization line, and we will be following mixed potential theory. So, lecture 29 is basically the topic, broad topic is passivation and mixed potential theory. So, the case 1, the effect of concentration of oxidant and mechanical damage of the passive film, or rather I would say effect of oxidant on the passivity and mechanical damage of the passive film. So, when we try to do that, and we will be considering activation controlled mode of cathodic polarization. This is one consideration, and second thing is the dissolving metal has active passive anodic polarization. So, when we have these two situations, let us see how we can get the idea of corrosion rate as well as mixed potential when we change the concentration of oxidant. Let us say the oxidant is OX plus E equal to reductant, and then corresponding E ox by red equal to E naught ox by red plus R T by F, since here we are considering one electron, Ln concentration of ox and concentration of red. When we say this, if ox concentration increases, then of course E ox red increases, and similarly if it reduces, this will also reduce. So, first we will try to see the increase in concentration of ox, and then the second part, this is the first part, and then second part we will see the decrease in concentration of ox after reaching the final concentration. In part 1, and when we see the second part, that time we will also see the effect of mechanical damage. Now, in order to do that, we have to draw mixed potential theory. So, let us say this is going to be my E versus log I plot. this is ampere per centimeter square, this is in volt. Now, let me first draw the anodic part of the passive active passive metal, and here we are considering E transpassive, ECP, and that means here we could see that ECP as well as EPP are at the same position. These are at the same position as per this particular diagram. This is I0 of m over m, this is E equilibrium of m. Now, this is the diagram, this is the anodic part where I can have metal minus Ne equal to metal N plus. So, this particular process is the anodic process, and this particular line indicates the anodic line. This is I critical. Okay. So, now when we have this situation, let us try to draw the diagram for cathodic line, cathodic polarization part. So, this is anodic polarization part, because this way anodic part. Now, if we go, let us start with concentration C1. So, the concentration, let us say this C1, and that time this is the anodic, this is the polarization part. So, this is E1 corresponding to concentration C1 of the oxidant, and this is I0 of ox over metal surface. Now, here we are considering I0 ox over metal surface remains constant for all the concentration. Beta C, which is the activation, the Tafel slope for the cathodic polarization, this is fixed for ox plus E equal to red, this reaction. So, if we keep changing the concentration, let us say concentration first increases, though this particular point will shift upward. So, it will shift like this. So, this is the second composition, this is the third composition, this is fourth, this is fourth, this is fifth, this is sixth, which is, let us say, just crossing the critical. This is the way it is moving. This is the seventh, this is eighth, let us say this is 9, and this is 10. and this is 11. So, we have taken 11 compositions. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 compositions we have taken. So, correspondingly we have this point is shifting, this point will shift, but there will be no change in the I0, that was the assumption we have taken, and E equilibrium value, E ox equilibrium, of course this is E ox, that will keep on increasing because we are increasing the concentration and that value is increasing, and beta remains same. So, that is what every lines are parallel, but they will have interactions according to the way they are cutting across the anodic polarization part of the dissolving metal. So, what are those points? So, this is one point, second, third, fourth, fifth, sixth, and then we have other connections also. This is 1, 2, 3, 4, 5. So, these are the connections or the crossing points, red colored circles. Now, if we try to see the corrosion rate, so those red points are the points where I could see that mixed potential theory is maintained. So, the red circled points, I could see that at that potential I C equal to I A. But as we have said, our initial condition was that the metal was freshly prepared and it does not have any oxide layer to start with. So, it will only see the circled point when the concentration of oxidant is increasing, and those circle points should remain, those points should be considered, which are basically the connection between the active part of the anodic polarization portion. So, this is the active part. So, this particular region is the active part, and of course, these two regions. So, the passive part, so this is the passive part, this is the passive part, and beyond this we have transpassive. Fine. So, as we are using the fresh metal, so we have to consider this point because it will only consider the cross section points of the active regions. So, the corrosion rate, if we try to plot, corrosion rate plot would be with concentration. If we try to plot, so this is corrosion rate, CR means corrosion rate. So, when we have C1, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is 11. So, now if we consider this, so the corrosion rate is at this point, let us say this is one point, this is the let us say to start with, this is the point. Now, as we are going up with a higher and higher concentration, I will see that the concentration is increasing, at the same time corrosion rate is increasing, because I could see that the corrosion rate was here, and then when the concentration has changed from C1 to C2, corrosion rate has gone to this, like that way the corrosion rate is increasing. So, 2, let us say this is the point, 3, this is the point, this 1, 2, 3, 4, 5, 6 all are concentration of oxidant concentration. So, then 4, I will have this point. So, 4 is if I try to see, the 4 is this one, then 5 is this one. So, 5 is still further increasing, it has gone to this. Now, 6th, when the concentration has reached to C6, which is this particular line we are considering, that is just crossing the C critical, I critical, it is just crossing I critical. So, since it is the fresh metal to start with, the corrosion rate would be here, not at this location, because we are starting with the fresh metal to begin with. So, now at 6 the corrosion rate would be equal to is equivalent to I critical. Okay, fine. Now, once we cross 6, once we go to 7, I could see that mixed potential is located at this particular location. Fine. So, now corrosion rate suddenly drops, and the drop in corrosion rate. So, this is corresponding to I passive IP. So, it will be similar to IP. So, if I try to see 7, so 7 the corrosion rate has moved to IP. So, now if I again start increasing my, and then it at this particular location, it will achieve stable passivity, because only one location it is cutting across that anodic portion. And now if I increase the concentration further, so if I go to 8 and then 9, so 9 is basically the location where the transpassivity is just starting. So, if it is just starting, so till 9 it will maintain the same corrosion rate, and then once we go to 10, this the corrosion rate will be, the mixed potential is satisfied in the transpassive zone, and I could see that the corrosion rate is increasing again. So, corrosion rate would be here, because I small I is nothing but the rate of dissolution. So, this is the location I could achieve, and 11 it is still further increases, it is increasing. So, it will be here. So, what will be the plot nature? So, the plot nature, as we increase the concentration from C1 to C11, the plot nature would be this will be the plot nature. Now, once we do this, after that if we decrease the concentration from 11 till 1, okay, if I try to do that, what will be the situation? Now, if I go to 11 to 1, if I draw with a different color, let us say I draw it with a blue color. So, in that case 11 the point would be, I am just drawing by the side of, by just below this particular line. So, this is 11. So, it will be here. If I do it with this color, this will be here, and then 10 it will be similar to this, it will be here. When I go to 9, I could see it is just crossing the passive to transpassive zone. The corrosion will be same as that particular current density of that anodic portion. 8, I could see that again that passivity is achieving. So, 8 I will be, corrosion rate will be this. 7, the corrosion rate would be here, because it is at this location. Now, when I go to 6, what will be the situation? If I go to 6, that means at this location as well as this location, 2 points, that particular polarization plot for the cathodic polarization is crossing the anodic portions. But since the passive layer has already formed, if the passive layer has already formed, if we do not disturb the passive layer, the passivity will maintain. So, it will not reach to the I critical, rather it would try to stay at I passive, because we are not disturbing the passive layer. So, if it does not disturb, so then in case of concentration C6, the current density would be at this location. So, current density would be same as this one. Okay. So, now 6, if I go to 5, so 5 I could see there are 3 points it is crossing, that this particular concentration, but since we are not disturbing the passive layer, the current density will remain here at this location. Similarly, it will be 4 in this case, it will be there, and 5 if I consider the concentration 3, I could see that it is just at the I passive to active transition zone, but still it is having a cut point at the I passive section and it is not disturbed. So, it will still remain 5 also it will be here and 4 also it will be here in the in the I passive zone, and 3 also if I see 3, this will also stay here. But once we cross 3, I go to 2, then I could see that the active passive at this mixed potential theory is maintained at this location. So, the corrosion rate should increase in case of when we go from 3 to 2. So, the corrosion rate would be at this location, and then if I go to 1, the corrosion rate would be at this location. So, the corrosion would be here. So, now what will be the plot? The plot nature would be, if I see the reverse train, when we change the concentration, it will follow this track and then it will move like this and then go down. So, the plot nature would be like this. So, in the forward scan, when we increase the concentration, the movement would be like this, and the reverse scan, when we change the concentration after reaching that C11, the plot pattern would be like this. So, in this case I am not disturbing the surface. Not disturbing the passive film. Now, if we disturb, what would happen? Let us say after reaching 6, that means 6 we have this point, which is basically the corrosion rate when we return from C11 to C6. At C6, initially the point is here without disturb condition, but if we now disturb, let us say the surface is scratched. Okay. So, once the surface is scratched, I am breaking open the passive film. So, once we break open the passive film, the system would try to achieve the corrosion rate at this location. Fine. So, instead of remaining here, the C6, the point would reach to this point. So, the movement would be this. Once we scratch the surface after reaching C6 concentration, and then once it is passive layer is broken, then after that if you decrease the concentration, it will always follow this track. Fine. So, then it will follow this track, it will follow. Remember, these points and this point both are the same location, but just to give you an indication that how the movement happens, that is what I have drawn it little away from the black point, black circle. Okay. So, the location would be, so the movement would be this way. Now, instead of 6, if I scratch it at after reaching C5, so then the concentration, then the movement would be this way. So, it will follow this and this and this, and after reaching C4, if we scratch it again, it will till C4 there will be nothing, there will be passivity, maintenance of passivity, but at C4 concentration I am scratching it, the movement would be this way. So, the corrosion rate will move to this location, fine. So, like that way this is the effect of scratching. So, the blue color is basically the scratching effect. Scratching effect, or we can say this is the mechanical effect, mechanical disturbance of the passive film. So, this is the way it should operate in case of active passive metal when we change the oxidant concentration from low concentration to high as well as high concentration to low concentration. So, let me stop here. We will continue our discussion on this very aspect, and we will take up 2 more instances where, or case studies where we could see the influence of active passive metal and when we consider mixed potential theory. So, let us stop here. Thank you.